Alright. We're rolling. So, today we're going to take a break from learning some stuff that requires some work. Alright, so there's not going to be any work associated with this lecture. Okay. What we're going to talk about is just the types of chemistry that exist out there, alright? We're going to kind of step aside and learn a little bit on what's out there and what chemistry overall kind of does and what it means. And we'll talk about a couple things that you guys are going to be using at some point, right? In this class, not in the future, but in this class. You'll see what those are. So the first one is, it's hard to call it my least favorite, but it's not easy, is organic chemistry. Alright? Organic chemistry, if you were to take a guess, has to do with what? Aside from just reading up there, right? You can read. But what does organic mean? Yeah, natural. It has to do with, organic is like, it has to do with life, essentially, okay? So things that are living. In this case, organic chemistry often refers to those four elements right there. It's pretty much, not exclusively, but it's pretty close. It's predominantly the four elements that are discussed in organic chemistry. And these are what?
Carbon,
Good?
nitrogen,
Good?
oxygen,
Good?
hydrogen.
Good. There we go. We're starting to memorize the periodic table, like it or not. So we're responsible for all chemistry referring to things that are living. Organic chemistry does a ton of work. There are tons of little subsections of organic chemistry, and we'll talk about kind of what at least one of them is really today. It does a lot with a very small part of the periodic table. Because, right, we have that whole thing over there, and we're talking about carbon, nitrogen, oxygen, hydrogen. Four elements out of everything that's up there. And we do a lot with it, right? Remember I said, I made the comment to you that carbon is pretty unique in the sense that it has how many lone electrons in its valence shell? How many valence electrons does carbon have? 4, right? So how many of them are all by themselves? 4, right? It's smack dab in the middle between 8 and 0, right? So it's pretty unique in that aspect. So you can do a lot with carbon. So we talk about things like medicines, right? We branch into a subsection if we want to talk about those maybe a little bit more. But organic chemistry overall, talk about making things like medicines. You can have what's called an organic polymer. Has anyone heard of that term before? Does anyone know what poly means? Good, it means many. So a polymer, long chains of what are called monomers. What does mono mean? 1. Good. So it's a accumulation of a bunch of monomers that create a polymer. We get things like, you get like really long carbon chains, you can make things like plastics, that kind of stuff, okay? And, this is a fun little fact more than anything else, in lab, in organic chemistry, one of the labs that we did was, we did this whole complicated step of what's called distillation, which is where you essentially evaporate something and you have it go through a super cool pipe. So part of it will turn back into liquid before it can evaporate out of the system, and the other part will completely evaporate out. That's distillation. We made something that smelled like wintergreen. Alright, so you get organic compounds that smell good. You get things like that are responsible for the smells inside of, you guys all like to chew gum, right? A lot of those things are probably, to some degree, synthetic, right? They're made, It's not like they're probably going out and getting all the plants in the world and putting it in your gum, right? It's not happening. So that's where that kind of stuff comes in. So organic chemistry can play into food science as well. And then we talk about all this mess.
Whoa.
Yep.
Do you
So
want us to write all that?
no. Just pay attention and mainly write about the important stuff that I'm talking about. Alright? So the first thing you want to write down is when we're looking at this, so these are all functional groups, okay? Organic chemistry enters this world where we talk about functional groups. Owen, you asked me about an alcohol, right? And what makes it an alcohol? Look right there. Yeah, but it's an alcohol, okay? That's what we refer to it as. You see what it has? What's it got? Oxygen, hydrogen, and then this right here, R, and this is important, make sure you note this. R, when you're talking about chemistry, you're not going to find an element on the periodic table that says R, right? It's not going to happen. What it means is everything else attached to it, right? R simply refers to anything else can be attached. We're just talking about this. Okay, so that's what R refers to in chemistry. So no, you don't have to memorize any of these. No, you don't really have to know any of these. But you've got things like, you see here, I mean, you can see why organic chemistry starts to get a little confusing, a little tough sometimes. Like, look at the difference between an aldehyde, a keystone, or a ketone, ester, and carboxylic acid. They all look pretty similar, but there's really small differences between them all. And if you get into organic chemistry, I promise you, you will have to memorize this. Alright? So these are functional groups. We care about these because certain ones we can make through certain reactions to turn into other things. Alright? So that's kind of what organic chemistry is all about. It's taking one thing and knowing that certain reactions go a certain way to be able to turn them into another thing. And that the attention's all drawn on the functional groups. Now this is how we draw it. We're going to go over this a little bit more in detail. No, you don't have to memorize everything on here either, right? But to reiterate, I want you guys to know the abbreviations, right? For example, this right here, right, would be, if I drew it out, would look like that. Right, because every time we see an intersection of lines, a corner of some kind, it's a carbon. If it's not labeled as anything, it's a carbon. And so the way we shortcut this is actually not even really what they have, but instead we would draw something that looks like that. And so, as you can see here, right here, it's this carbon at the end. What is attached to this carbon right here that I don't show? Hydrogen. Good. So know that because carbon can form how many bonds total? 4. Good. If it's only showing one bond, which is what's shown right here, right? It's implied that everything else on it is hydrogen, Okay, so that's something you'll need to know as well. Alright, so however you want to note that.
What did you say?
Huh?
I was too busy writing something out. What did you say?
This carbon can form 4 bonds. When it shows less than 4 bonds, the rest of the bonds to add up to 4 are implied that they're carbons bonded to hydrogen. Okay. So that's how that works. So don't get caught up in the super confusing way above what we're talking about kind of stuff where we're really getting into functional groups. Don't worry about what all these are and what they mean, and just focus on what's a carbon, right? So, how many carbon does this have? Someone tell me. How many carbon does this one right here have?
4. Wait,
Nope. Who said 7? Good. Watch. 1 on the end. 2, 3, 4, 5, 6, 7. Okay? Remember, each little corner, end of a line, anything like that is considered a carbon. Now let me ask maybe a harder question. This hydrogen right here in the middle of this little 3-pronged thing going out, how many hydrogen does it have attached to it?
2,
Nope.
3, 6.
Nope.
8.
8. How many bonds can carbon form?
4. Wait.
Up to 4. So does it make sense for it to have 8 hydrogen attached to it? No. This one right here.
1.
Good. 1.
Wait,
Yes.
what?
Good.
Because they're connected. Oh.
Why?
Because they're connected together, and so.
Right? There's 3 bonds to another carbon, right? This carbon's bonded to that carbon, and that carbon. So it's implied that if it's already 3 bonds, and we can bond up to 4 times, which we've said, we know that, the one remaining bond is a hydrogen. Right. Okay, good. We'll get some practice with this. Not today, alright? I told you I'm not giving any homework today, any work to work on. That'll be tomorrow's problem. You just expect to come to class and never get work or what?
Yeah,
Yeah?
pretty much.
That'd be nice, wouldn't it?
Yeah, it would.
I wouldn't have to grade anything, you
We're
wouldn't have to
spoiled.
learn anything.
Just give us all
We're
grades.
spoiled.
We could just sit here and do nothing.
Why don't
We
we
could
just?
just play with those model kits.
I would love to.
Speaking of the model kits, those should be in today, I
To be
would
fair,
think.
last time something was supposed to come in, it didn't come in until.
Last time something was supposed to come in, it did come in, and Miss Hayes mistook it for being in a different box. She thought it was something else when it actually was my stuff. So it did come in when it was supposed to.
Wait,
I just didn't have it.
Last one?
Yeah.
Let's go.
When as we're moving along, the next time it is applicable to do a lab with what we're learning, we will be doing a lab. So you can expect one, more than likely. I haven't made a lab, I haven't gotten that far ahead, right? But you can expect one within the next 1 to 2 weeks. Okay.
Okay. Wait, we don't have much days of school left, do we?
14 Fridays.
Oh, that's
14
not
We only
Fridays.
have a couple.
But we
We
also
have,
have
like,
spring break.
I think that not counting spring break is 14 Fridays.
Still happens.
The spring breaks are like a week.
All right. Moving on. So the next, if we had organic chemistry, then what else should we have?
Inorganic.
Wow, you guys are on it, right? Totally not up there on the projector, right?
I love you saying that.
So, if organic means it deals with life, then we can imply that inorganic means it deals with not that stuff, but what? Not death.
Not living.
Things from
Mhm.
organic chemistry combined with things not.
Okay. So it involves things that aren't a part of life, right? They're not biological. So that middle part that I've told you guys that we ignore a lot of, the transition metals, right, on the periodic table, if you look over there, it goes from here, from scandium, I do believe that is, all the way to zinc, right?
So how would that work since we have it 1, 2, and then the rest is 3, 4, 5, 6, 7, 8?
Valence electron wise?
Yeah. How would you name?
Because there's 10
number
of
that?
them, right?
Yeah.
I would have to go into a topic and explain some stuff that is a little complicated, alright? So in essence, just know, I'll just tell you this. There are 10 of them.
Yeah.
If the rule is we count from left to right, 1 to 8, what do you think we start at?
3 to 12. 9.
You're close, you're
9.
close. We would start at 1,
Oh.
okay? And we would go to 10. Yeah.
Why?
Why? That's the hard part to answer. It has everything to do with molecular orbital theory.
Does just 11 and 12 just not matter then?
It doesn't well, it exists, but it exists down there.
But then
In that weird part of the periodic table.
That's so confusing.
Yeah. So I'll tell you now that if you are genuinely curious about that, right? I want to know. Try to get into things like if you're curious about how that works and you want to look at chemistry more, get into ICP, get into chemistry.
When
Those
do
are
you get
things
an
that I'll.
ICP?
Huh?
Next year?
Um,
I'm biology.
I don't know what they're offering. I think most freshmen take biology. But it has to do with my ICP students have learned about molecular orbital theory, okay? So if you want to know about that kind of stuff,
I'm taking honors English.
you have to take that class. Or if you're really curious now, I do like I said, on the YouTube channel that I have ICP lectures as well. So if you're that adamant on learning about this stuff, you can go watch that kind of stuff, okay? You go watch it there. I doubt any of you will. I mean, I wouldn't have as a student, so. So anyway, inorganic. So things that are not living, the transition metals, a lot of the stuff in the middle. So, and organometallics, that's the wheelhouse of inorganic chemistry. So it takes the metals, the transition metals, and applies them to things that organic chemistry deals with, which are what 4 elements?
Hydrogen,
Good.
nitrogen, oxygen, and carbon.
Good. So, this covers, this is not an exhaustive list, but like this covers a lot, some of it anyways. Things like computers, the chemistry and how computers work, right? Because there are elements in computers, and that applies to just like electronics as a whole. Gems, crystals, different types of like, I put metals, but really I should have put alloys, right? Like we have different kinds of like iron and copper, and you know you get different alloys and combine the two of them. We talked about that as a solution, if you remember. And the way more. And then you've got catalysts too, right? So those are just examples.
What is that?
What's a catalyst? A catalyst is something that either allows a reaction to occur in the first place. It makes it, I shouldn't say allows, it makes it a lot easier to happen, or it makes it happen faster. Those are kind of the same thing almost, right? If something's good at something, like doing a reaction, and then we add a catalyst, it becomes really, really good at doing that reaction, right? Or if it can do the reaction but really doesn't want to, we can add a catalyst and then it says, oh, okay, I'll do the reaction. That's in essence what a catalyst does. So, check this out.
Oh, my sigma.
Yeah.
Why is it built like this? Do we have to do this in high school?
This kind of stuff, you'll come close to it. If I have my ways and get into chemistry and things like that, and I start teaching that, which is probably going to be the case, we'll touch on some of this stuff. But it won't look so complicated.
What classes do you teach?
Right now,
Yeah.
8th grade science, ICP, environmental science.
You don't teach
What grade's
biology?
ICP? Will you next
So-
year if you get your way?
If I teach biology, will I teach biology?
Yeah.
No.
Oh man, you should.
That's what we all have.
That's what all of us have to do.
I will not be teaching biology.
Wait, who do we
Are you
have?
taking
We'll probably have Miss Hobbs.
Probably, as of now, you'll have Miss Hobbs. I'll tell
I don't
you,
know how she teaches.
I'll tell you, I don't think it's a secret, that they want to get somebody else. So
I
Guess
think
my
A new
you
teacher.
Yeah, you still mess with me.
No, they want to get some else because she doesn't want to be working.
well, it's not. Yeah, right. She's very, very busy.
So is Binkley.
She's
so.
assistant principal and teaching, and
Yeah,
Mr. Binkley's the same way, right?
Wasn't Binkley gonna stop too?
Yeah, that's the plan. He's gonna. I know there's a couple classes he still wants.
I saw Mr. Rich
But-
comes back. on
Mr. Richie, I'm talking
My
about.
plan, what I would like to teach that I have said I want to teach. You guys are distracting me, but whatever.
No, wait, that's not.
I want to teach chemistry, ICP, anatomy and physiology, because that's my wheelhouse when it comes to. I mean, that's what I did for 3 years before I came here, right? On the ambulance was applied anatomy and physiology. And then, this is not a promise by any means, but I am working on trying to get the school and figure out how I would do it logistically on board with offering, you know how there's vocationals, right? I want to get a EMT vocational offered here at this school. So what that would look like,
Wait, what's a vocational? Like
that's like, you go do something outside of your normal daily school schedule.
so like is it like half day and then okay? So like if you're
How
gonna
would
do
we
something,
learn
you would
that
go
here,
to
though?
clinic.
How do we do that here?
Half day.
So what I would do is, you'd have to really want to do it, because my plan is to make it an evening school. So it would start in the summer, it would be in the evenings, it would meet probably 2 times a week for 4 hours each time. So it'd probably be like a Tuesday, Thursday from like, I don't know, 3 to 7 or 4 to, it'd probably have to be like 4 to 8, right? Tuesday, Thursday, start in the summertime, and then it'd run until about October. So you'd have to double up on it for a little bit in the fall, during the week.
How long do you have to go to college for to be an EMT?
You don't,
You don't?
you just have to take the class, and then pass a couple tests.
I could so totally do it.
What if we have like sports that are
Then you probably wouldn't be able to do it.
Callie, what's your schedule on biology?
So it'd be a fall
She has
thing.
both of them,
But it's also, if it's a sport issue, it only meets the classical.
I'm taking honors biology.
This is not a guaranteed thing by any means of the imagination. This is just something I'm working on.
We'll start a petition for you.
So this is something I'm working on.
Go
Thanks.
fund me.
So
What
actually,
is
it's the
biology?
funding I should be able
It's
to
a
have.
science class.
I get that, but
Isn't it?
Like chemicals?
It's
No. What's bio mean?
no, not
your body.
Yeah,
Means,
why would
bio means life.
So why we not?
Oh, I
I
got
don't want to take biology.
We gotta keep
Oh, I have
it
to.
Alright. Back on topic.
We are not talking.
No, we're not. So, I got what? A little bit over 10 minutes. So this right here is an example of a metallic structure, right? You see how it's an organometallic, right? What do we have? Oxygen, carbon, right? So there's some stuff from organic chemistry. And then we get into some metals. Alright, and so, now remind me, this was a bonus question.
Oh wait, what?
What do the filled in wedges mean?
Oh, you can. It like
Oh, I
comes
didn't
at
answer
you.
it.
Good, it's coming at you, right? And then this
Oh, wait.
case they're not wedges, but what's the dash mean?
Oh wait.
Good. So this really, realistically, looks like what?
diamond?
Yeah.
It-
Yeah. Like a 3D, like kind of
A
like
rhombus.
it's not a diamond, right? But it looks like a diamond. Okay.
Rhombus.
And then we get into the bane of my existence, analytical chemistry. So this is like if physics, computer science, and chemistry had a baby.
What?
Yep.
Dad, you're kind of farting.
So what it focuses on is it focuses on the machines that we use to interpret data from chemicals, right? From compounds, from structures. So you have to know how computer science works a little bit, you have to know how physics works a little bit, and you have to know how chemistry works, right?
That's a three-way marriage.
Yeah, that's what I said. If all three of them had a baby, which wouldn't make any sense, right? But So an example of this, there's a couple of them, and I'll show you. We're not going to get into it super detailed, but it's a sneak peek. You have what's called an NMR machine, and then you have IR spectroscopy. Okay, I have physically messed with both of these when I was off in college. So the first one, this is an NMR graph. Okay, it is on canvas. So what this does is, in short, this carbon, and then this. What is this? OH. What is OH?
Oh,
What's it called? What's the functional group? The one I actually told you the name of.
OH.
Yeah. What's it? What is it?
It's OH.
What is it, Owen? What's OH?
Oh, and I thought you're smart.
No, but what's the name of
Oh,
it?
isn't it?
Alcohol. There we go.
Yeah.
Sorry, I didn't hear you. Right? It's an alcohol. Right?
I don't know if I was wrong about
So these all pop up and form a peak at different spots based off of what we've got going on down here. So that's how NMR works. And then very similarly, we have IR spectroscopy.
Types of chemistry and biology.
And the graphs look like this. So you get this big fancy molecule here. What's this ring called again?
Oh,
Benzo.
Benzene ring.
It's
Benzene. Right? But good. Good. Okay. And so, based off of what you've got going on in the structure, you also get different formations in the IR spectroscopy. This looks at the bonds. Okay. And then you have a subsection of organic chemistry, really, kind of, that's biochemistry. So this is where you'll take biology next year, right? A lot of you are taking biology. And then, so it's basically going to be what you guys learn, and then you apply chemistry to it as well. You get biochemistry. So this looks at things like proteins, enzymes, all kinds of cellular markers in your body. Okay, you have a lot of your cells identify themselves as certain things based off of flags that they put up in short. And so this is a non-exhaustive list of all kinds of proteins in the body. Right? Can you start to understand why in biochemistry, and like I said in chemistry, why I wouldn't want to draw these out by hand every time? Or at least show all the carbons, and why I just show little intersections of lines, right? Because this would be a pain in the rear, right, to put every single carbon. I mean, they did it in this, but if I wanted to draw that, I could do it a lot quicker by using the shorthand. Kind of the method that we discussed just a little bit ago. Yes, yeah, that's what benzene looks like when you actually show the carbons. Here, right? So, and then there's things like forensic chemistry. Oh, speaking of which, I think the school's trying to convince me to teach forensics. Somebody gets murdered and you take all the evidence and compile it.
That's kind of cool.
That's what forensics is.
Can we do that?
It's the studying of, it's using science to investigate a crime scene.
Wow, that's actually kind of cool.
So,
I feel like I could.
that's an elective though, so, and that's not till you get a little bit.
Do we have to sacrifice someone to do that?
Probably.
Oh, you can sacrifice me. I volunteer to tribute.
You volunteer?
No, you can't take
I
my
volunteer
tab.
to distribute.
Okay.
Yeah, I feel like I'm the most lore, so I can go.
So forensic chemistry is a thing, right? So crime
Go
scenes.
together.
Agriculture has chemistry, has a field of chemistry. There's nuclear chemistry, right? So creating energy, environmental
Nuclear
chemistry.
bombs, who would make a bomb?
Yeah, but more importantly, like nuclear chemistry is like nuclear power plants, that kind of stuff. Nuclear submarines.
Or what if we just, yeah, you can't hear.
Actually,
Alright, and that is all that I have to discuss today.
Yay!
so what?
Wait, will we have a discussion tomorrow?
A discussion?
Yeah.
Or-
Jealous.
Your thing.